Hi guys, this is part 2 of the 2026 FRQ unofficial answers with FRQ 3 and FRQ 4. Now for FRQ 3, we're told that there is a circular water wheel that rotates in a counterclockwise direction. So that means in this direction, and it completes one revolution in 10 seconds. At time t equals 0, point W is 6 feet above the center of the water wheel, and then the height of point W periodically decreases and then increases as the water wheel moves. So for question A, we have to label potential coordinates for this sine wave or cosine wave, and then we can have a start at t equals 0. So the prompt tells us that at t equals 0, W equals 6. So this will be 0, 6. And then the prompt also says that the wheel completes one revolution in 10 seconds. So that means 10 seconds after, it will be at the same distance, which is 6 feet from the center. Then, based on the distances, we can find that J is between 0 and 10, so it must be at 5. And then that is when the W is here, so that means this would be -6. Then point G is between F and J, so between 0 and 5. So that one is 2.5 and 0, because that would be when W is here and there is no distance from the center. And then finally, for K is between P and J, so the X value is between 5 and 10, which would be 7.5 and also 0. And this is where K would be. For part B, we have to write function h in this form with the constants a, b, c, and d. So the constant a is the amplitude of the sine wave. So we can see from the graph up here that the amplitude will be 6. Next, we have to find b, which is how often the graph repeats, and b equals 2 pi over the period. And the prompt tells us that the water wheel completes one revolution in 10 seconds. So that means the period is 10, and then b equals 2 pi over 10 equals pi over 5. And then d is the midline of the graph. And then we can see from this one that the midline is y equals 0. So d equals 0. For C, it is the phase shift. So a sine function usually starts at the midline, goes up, and then goes down, and then goes back up. So this point would be -2.50. And that's how far the sine wave was shifted. And because it was shifted to the left, you have to make C positive, and C equals 2.5. So all of the constants, A equals 6, B equals pi over 5, C equals 2.5, and D equals 0. For question C, we have to look at point J and point K, and we have to see on the interval of T1 to T2 what is true about H. So J is right here and K is right here. So we can see that the function h is increasing and is also negative because the y value is -6 to 0. So the answer for that one is negative and increasing, option C. And then on the same interval, we have to describe the concavity of the graph h and determine whether the rate of change of h is increasing or decreasing. And here we can see that the rate of change is increasing because the graph is getting steeper. So we say the graph is concave up. Now for FRQ 4, we are given all of these instructions and guidelines. And then for question A, it tells us to solve g of x equals 1 over e to the 6. So we set g of x, which is e to the 2x, equals 1 over e to the 6. And we can rewrite 1 over e to the 6 as e to the -6. So basically we just have e the 2x equals e to the negative 6. And then you can take the natural log of this and get 2x equals negative 6, x equals negative 3. For part 2, we just have to solve h of x equals 3. So log base 2 of 5x equals 3. And then you just put 2 to the power of this. So 5x equals 2 to the third power. And 5x equals 8. X equals 8 over 5. For question B, part 1, we have to rewrite j of x as an expression of the form 7 to some expression. And this is j of x. So we can use the product rule for exponents. So 7 to the 3x plus 1 times 7x equals 7 to the 3x plus 1 plus x. So in the end, it's 7 to the 4x plus 1. So 4x plus 1 is the expression. For part 2, we have to write k of x as an expression where sign appears only once and there is no other trig function. So we can see that there is sine of 2x. So you can use sine double angle, which means sine 2x equals 2 sine x cosine x. And then we can rewrite secant x as its reciprocal function, which is 1 over cosine x. So you can cancel out cosine x on both, and we are left with k of x equals 2 sine x. Finally, for question C, we are given m of x equals tan squared 3x, and we have to find when this function will have an output value of 1. So we set tan squared 3x equal to 1. So we take the square root, so tan 3x can equal 1, or it can equal negative 1. So we can do this one first. So we think about when does tangent of theta equal to 1? And that is when that's when theta equals pi over 4 or 5 pi over 4. And then we see that theta equals 3x. So we have to divide both of these by 3 to get x equals pi over 12 and 5 pi over 12. Next, for when tan 3x equals negative 1, we have to find the values of theta for which tangent of that theta equals negative 1. And that is 3 pi over 4 and 7 pi over 4. Then we divide both of these by 3 because 3x equal to theta, and x equals pi over 4 and 7 pi over 12. And then we look at our restriction, which is the interval from 0 to pi over 2. And we can see that all of these values are between 0 and pi over 2, except for 7 pi over 12. So our final answer is x equals pi over 12, pi over 4, and 5 pi over 12. Also, these solutions are based on my own understanding of the questions and are not official. Once the official solutions come out, if my